Good day, everybody. Let's divide our labor just a little bit on this cube root summation of a bunch of ones problem. Cube root of x, we'll just pretend like x is this entire summand here, or summation symbol. The cube root of x equals to 8 certainly intimates that x is equal to 8 cubed if you cube both sides. And that's 8 times 8, which is 64, and 8 times 64 is 512. So it's useful to do that computation at the very beginning and then worry about how to manage the summation at this upcoming stage here. So that's 512. Now, let's move along. This summation, I would call it slightly tricky, and I'll just work with a concrete example. What if we did summation... Let's just keep the numbers simple here. Let's say I equals to 8. I equals 8 all the way up to 10. Now notice the summand has no dependency on the index here. So that just means we're going to add this up, add 1 up 3 times. Now, this has always been a little bit confusing for a lot of people, myself included, when I first started dealing with summations. The tendency is to go 10 minus 8 is 2, right? But really, there's 3 summands here. Okay, so in this case, we would get 3 for these concrete choices. But notice that that is the same thing as 10 minus 8 plus 1, okay? And of course, nothing changes when we're dealing with other integers. These are just arbitrary here. But so in the very same breath, we can go ahead and, without any reservation, state that this has to equal to n minus m plus 1. Okay? So again, this plus 1 always looks strange to me when I was doing discrete math, but it's really pretty easy, all right? So once everything's easy, right? Once you see what's going on. But now let's go down and solve the problem. What we know from up here, we know that the summand has to be equal to 512. So that, let me just write that in. This statement right here in the above arithmetic implies that the summation I equals 25 to k, which is what we're looking for, the upper limit or whatever you call it. Okay, k is an unknown, the only unknown in the problem. We're summing up a bunch of ones. Okay, we know that that has to equal to the 512 that we from up here, right? So we'll write down this is equal to 512. But from the work we just did right above, what does that mean? That means that k minus 25, excuse me, that means that k minus 25 plus 1 has to equal to 512, right? Again, this stuff is, you could do this in your head, really. I'm being slightly too formal, probably. But, so in any event, what does that give us? That would mean that k is equal to 512 plus what, 24? That's what I'm getting, ladies and gentlemen. And so I'm getting 536, final answer. Okay, and I don't think I made any arithmetic mistakes, but 536 would be the value of k here. Let's see, that would, if you, however you want to think of it, if you subtract 1 from this side, you get 511, then if you add 25, you get 36. Or you could just say this is k minus 24, add 24 to 512, and you get the 536. Anyway, the 536 is the final answer. I like these sort of problems. They're not hard, but it's real easy to look at it and kind of forget that you have to add the 1 in that particular formula. So anyway, hope you enjoyed.